Good morning, everyone. Welcome to this workshop on Publish Your Own Routing Services. I am Dilesh Mandloy, and helping me is my colleague
Max Zhang.
We both work as product engineers on the network analyst team out of our Redlands office. So before we get started, all the slides as well as the demonstrations that we will show today are available for you to download at this URL. So what we are going to cover today is we'll look at some very brief routing concepts so that if anyone is not familiar with routing, they can get an idea of what we are talking about. Then we'll look at what is the publishing workflow when working with ArcGIS Enterprise. Within that, we will see how you can publish routing services as geoprocessing services or as map services with network analysis capability. And then finally, we'll look at how you can use these network analysis services. So now let's look at some of the routing concepts. So routing in ArcGIS software is done as part of the network analyst extension. This extension is used to do analysis on transportation networks. The transportation networks are essentially what models your streets or your multimodal networks. These are different than what your utility networks like your gas, water, or electricity networks are. Network analyst and this workshop is not about utility networks. We are going to talk about transportation analysis. Within network analyst extension, there are 6 different analyses that are available. You can think of them as 6 different analyses, 6 different solvers, or in the context of this presentation, you can actually publish each of those solvers as services. So you have 6 solvers which you can publish as 6 different types of routing services. So these are here in this slide, I'm showing you a categorization of how to think about these 6 different solvers. So first on your right is point-to-point routing, where we have the route, closest facility, and origin destination cost matrix solvers. Now the route solver allows you to find the best route between 2 or more stops with the option to optimize the sequence in which you visit the stops. The stops can have time windows and can also use live or historical traffic when available. The closest facility solver allows you to find 1 or more closest facilities from a given incident. For example, you might have an accident and you might want to dispatch the 3 closest police cars to that accident that can reach that location within 5 minutes. The origin destination cost matrix solver allows you to find the travel times and travel distances between all of your origins and all of your destinations, optionally specifying the number of destinations to find from each of the origins and also a distance or a time-based cutoffs. Next up is the optimization solvers. So the first in that is the vehicle routing problem solver, which allows you to find routes for a fleet of vehicles. Let's say you're a delivery company and you want to deliver to 25 different orders and you have 3 drivers. So this solver can allow you to figure out which order goes to which route and in which sequence the route should be visited. There are other constraints such as time windows and breaks and whether the maximum working hours for your drivers, all of those can be incorporated into this solver to produce the optimal routes. Next is the location allocation solver, which allows you to find best facilities that service demands. For example, you may have 2 existing stores and you may have budget to open 2 new stores. So this solver can figure out where do you open those 2 new stores, keeping your 2 existing stores such that your market share is now 90 or 95%, or such that 89 or 95% of your customers are within 10 minutes of at least 1 store. Last is the service area solver, which allows you to determine the coverage from 1 or more locations. So this can be used to figure out what are the trade areas for your stores. For example, how many customers are within 30 minutes of each of your store. In the previous slide, we looked at what are the different types of solvers or analysis that you can have access to when you're working with network analyst. This analysis is done on a network data set. This network data set essentially models your transportation network. Here is where you have all of your rules that govern traveling on your network. For example, your one-way streets, your overpasses, your underpasses. So all of this is put up in a data model, which in ArcGIS terms is referred as a network data set. So the routing or the network analysis is always done on a network data set, which is stored within a geodatabase. So without a network data set, set, you cannot do any of these analysis even when you are working with services. The services are essentially using the network data set, using the solvers, and providing you a service that you can use from many different applications. So where do you get a network data set? Esri has a product called StreetMap Premium, which comes with a high quality, ready to use network data set. This product also has an option whereby you can buy the StreetMap Premium, and in case you want to add your own street data to it so that you can augment that street data, that option is also available. That product is called StreetMap Premium Custom Roads. You may want to build, you can build the network data set using your own organization's data. For example, ArcGIS Pro provides you local government tasks that can help you create a network data set from your own data. Or you might create data from government, or you might create network data set from government data such as Tiger, or even open source data such as OpenStreetMap. Finally, if you don't have any network data set, ArcGIS Online allows you to have access to services which you can just call. In this case, you won't need ArcGIS Enterprise, you're just calling services that are already available to you. Now we saw the routing concepts. Essentially, we have 6 different types of analysis available in network data set. All of those analyses have to be performed on a network data set, and from where we can get those network data sets. Now let's look at ArcGIS Enterprise. Now this workshop is not going to go in much details on ArcGIS Enterprise. I'm trying to give you just the basic ideas on how ArcGIS Enterprise fits in when you're trying to work with routing services. Now this is an illustration that I like to explain ArcGIS Enterprise with. As I was talking previously, you do your routing services based on a network data set. So that's what you store on your servers. You can have one or more servers where you're running your GIS services, or in this case, your routing services. These servers federate to an enterprise portal from where different applications such as ArcGIS Pro or Mappier can discover these routing services and can use these routing services. This essentially what enables WebGIS in your infrastructure. This infrastructure can be on your own premises, or it can be in the cloud that you manage yourself. If you have used ArcGIS Server before, you might be wondering what is ArcGIS Enterprise. ArcGIS Server had its name changed in a previous release, and it's called now ArcGIS Enterprise. So ArcGIS Enterprise allows you WebGIS, which essentially means you're working most of the times with the GIS services. So what is a GIS service? A GIS service is essentially a GIS resource running on a server machine. Contrast this with a GIS application such as ArcMap or ArcGIS Pro that runs on your local computer. A GIS service, in contrary, is a resource that's running on a server. To achieve GIS services, you essentially share GIS resources to the web using one of the different service types that ArcGIS Enterprise allows you to publish. For routing, we will focus on 2 different service types: network analysis and geoprocessing. So now let's see how you go about publishing routing services using those 2 service types. Now, before we get into that, I often get this question asked by a lot of users saying, should I use ArcGIS Online or ArcGIS Enterprise? Both of them have routing services. Now this decision should really be based on whether you have your own street data or not. Your own street data or street data that you can get as part of StreetMap Premium. If you don't have any street data, then you have to use ArcGIS Online services, which require service credits but nothing else. So that option is easy. But let's say if you have ArcGIS if you have your own street data, then do you have ArcGIS Enterprise with a network analyst license? If the answer to that, if you're either missing ArcGIS Enterprise or network analyst license for ArcGIS Enterprise, then again, if you want to perform routing using web services, you have to use ArcGIS Online. But if you have ArcGIS Enterprise and a network analyst extension for ArcGIS Enterprise, then then you can go ahead and publish your own routing services to your ArcGIS Enterprise. When you're publishing GIS services, or for that matter routing services, to your ArcGIS Enterprise, you always follow this 3-step workflow. You author a GIS resource, you publish that GIS resource to get a service, and then you share that service in your organization and use that service from many different applications. So keep a note of these 3 steps, and we will see how you actually go ahead and implement these 3 steps in subsequent slides. To publish routing services, you can publish them as 2 different service types. Remember, ArcGIS Enterprise provides you access to a lot of different service types, like a geocoding service or a map service or a geoprocessing service, out of which to publish routing services, you can either publish them as a geoprocessing service or you can publish them as a map service with network analysis capability. In the REST API and also throughout the user interface, like in ArcGIS Server Manager or ArcGIS Services Directory, you would often see geoprocessing services being referred as GP server and map service with network analysis capability being referred to as NA server. Just want to put out those 2 terms so that when you are looking at the documentation, you can make this connection between GP server and a geoprocessing service, or NA server or map service with network analysis capability. So now let's look at how do you publish a geoprocessing service. Remember the 3-step workflow: author, publish, use, and share. Author, publish, share, and use. So in the illustration on the right, you can see in order to publish geoprocessing service, you need to first have a geoprocessing script tool which is powered by Python code that uses the ArcPy and the ArcPy.nax modules. Once you have this script tool, you run this script tool in ArcGIS Pro and publish the result as a web tool. Once you have published the result as a web tool, you have got a geoprocessing service that you can share with others, and then you can start using this geoprocessing service from applications such as Mapfier, ArcGIS Pro, ArcMap, or programmatically using ArcGIS APIs or SDKs. So those are the 3 steps. You have your geoprocessing script tool, you author your geoprocessing script tool, you publish that, and then you use. Next service type is the map service with network analysis capability. In this case, the resource, the GIS resource that you're authoring is an ArcGIS Pro map with 1 or more network analysis layers. So in the illustration on the right, you can see I have a Pro map with 3 different network analysis layers. The next step I do is I take this map and then I publish this as a web layer. When I'm in the process of publishing this as a web layer, I have to make sure I enable the network analysis capability. This step is important because without this, you are only going to get a map service without any network analysis capability. So enabling this capability is extremely important to get actually a routing service alongside your map service. Then once you have your service published, you can use this programmatically with ArcGIS APIs and SDKs. Unlike the geoprocessing service, the map service with network analysis capability cannot be used from out-of-the-box applications. You have to use them programmatically with the APIs and the SDKs. In the previous 2 slides, I told you about 2 different service types: geoprocessing services and map services with network analysis capability. To simplify this process, ArcGIS Server includes a tool called Publish Routing Services, which essentially takes a network data set and publishes all of these routing services. So instead of doing this one by one using ArcGIS Pro, we are providing you with an automated tool that can take a network data set and can create all of these routing services. Publish Routing Services utility, as I was mentioning, is included with ArcGIS Enterprise 10.6 or later. If you are publishing routing services to a federated GIS server, the tool registers all of the routing services as portal utility services, and this tool requires a network analysis extension for ArcGIS server. So the tool takes your network data set, some connection information about your server and your enterprise portal, and then when create all the different types of routing services and also register them as portal utility services if your GIS server is federated to an enterprise portal. Now, this figure is showing you what are the different types of services that are created by Publish Routing Services tool. So it creates a network analysis geoprocessing service that gives you 6 different tools to work with each of the 6 different solvers that we have in Network Analyst. It also publishes a map service with network analysis capability. It creates a synchronous geoprocessing service that you can use to access some of the solvers in a synchronous execution mode, and it also publishes a utility geoprocessing service that allows you to work with travel modes available on your network dataset. Along with publishing these services, if your enterprise server is federated with a portal, then this tool will go ahead and register these services as utility services. Now, this is important because this is what allows all the different applications to discover these network analysis services or routing services and work with them. Now, a small trick or a tip you can think of when you're publishing services with Publish Routing Services utility is, how do I update these services? Let's say if you're moving up from ArcGIS Enterprise 10.7.1 to ArcGIS Enterprise 10.8. You already had run Publish Routing Services in ArcGIS Enterprise 10.7.1, and once you upgrade, those services are automatically recreated in ArcGIS Enterprise 10.8. However, what I'm recommending is once you have upgraded to 10.8, you delete your existing routing services and then republish them using Publish Routing Services utility. This way you will get all the new capabilities that are added to these services at every release. Also, if you are upgrading street data, let's say you had StreetMap Premium Release 1 data and now you got StreetMap Premium Release 2 data, the best option is to delete all the existing routing services and then to create new ones by running Publish Routing Services utility. The tool guarantees that the services will be published at the exact same URL using the exact same API. So by deleting and recreating services, it's not going to break any of your existing applications that rely on these services. Once you have published the routing services, you can use them from many different applications. Like in the Map Your application that you get with your enterprise portal, you can use the routing services from the directions button or from many different analysis tools that are within the use proximity category. From ArcGIS desktop applications like ArcMap or ArcGIS Pro, you can use the services by making a connection to your GIS server, and then in ArcMap, these services will show up as geoprocessing tools. Or if you are in ArcGIS Pro, you can go to the network analysis gallery, set your network data source to your enterprise portal where you have published these routing services, and then you can use them from within the network analysis gallery. So with that, I'm going to hand it over to my colleague Max, who will show you a demonstration on how to work with the Publish Routing Services utility.
Okay.
On to you, Max.
All right. Thank you, Dilesh. So as Dilesh mentioned, the best way to publish your default routing services is by using the Publish Routing Services utility. It takes care of authoring, publishing, and configuring for you, so you don't need to do on your own. And it also embeds some performance tricks, so you are guaranteed to have the best routing services published using the utility tools. And we started to ship these published routing utilities in ArcGIS Enterprise in version 10.6, and it started as a Python script. You can use the server Python to call it. In version 10.8, we improved it slightly, so it's now a batch file, making it even easier for you to call this functionality. So let's now open this command prompt and see how we can use it. On this machine, I have installed 10.8. So what I can do is I can go to my server install folder. And here we have tools folder. And within that, we have the published routing utility services folder. And we can take a look. We have the published routing utility services.batch file. So what we can do is we can do a -h to see what are the options that these utility services take. So it takes the username password, which is the primary set administrator for the server, or for the portal if your server is federated with the portal. And then the server name and portal name, which is the domain name of the machine, fully quantified domain name of the machine. And you provide the portal name only if the server is federated with the portal. And it takes in the network dataset path. And then the service definition folder where it will create the service definitions within this folder along with the log while the tool is running. And then by default, the services will be created on the server in the service folder called routing. And if you want to change the service folder, you can specify this parameter. And this gives you the detailed overview of how to run this tool. And we also have a documentation which is already in Delight's slides. You can get the URL to this documentation. So to use it, we can do -u admin, -p secret, and -n network dataset, or whatever. But if like me, if you want to save some time, what you can do is you can create this param file. So in my param file, I specify all the parameters. So what you can do here is you can copy this path to the param file, and you can do an add with your param file name. So this takes care of passing the param file one by one to the batch file. So once I hit enter, it's going to run, and it takes about 15 to 20 minutes depending on how fast your machine is. And to save us a little bit of time, I've already run it. So let's take a look what it creates for us. So here on my server manager, I got this routing folder. So let's say the default folder is going to create the services within. And we have the network analysis geoprocessing service, which is an asynchronous geoprocessing service, and one task for each of the solver we have. The network analysis map service, which is a fast synchronized network analysis service. And we also have the synchronized version of the geoprocessing service. And then the network analysis utility service, which is used by other tools or services. And by the time if you publish your service and your server is federated with the portal, and what the tool is going to take care of is register all the utility services on the portal. So here I have my portal sent in with an admin account. So I can go to Organization, Settings, and under Utility Services, scroll down to the bottom. We have the Directions and Routing Utility Service configuration. So what the tool takes care of is it registers any of the services you publish to your server to the utility services in your portal. So if by the time when you publish the service, when you use the utility services to publish your service, if your server is not federated with the portal, then this is not going to be done for you. And if you later federate your server with the portal, then you have to do this manually. So why do we need to federate set up all the utility service on the portal? Because after this, all the out-of-box apps like ArcGIS Pro, Map Viewer, and Web App Builder will just work. So let's take a look at the Map Viewer. So within Map Viewer, we have the Directions button, which help you to find a route between A and B. And why it's working, because we have already setting our route utility services on our portal. It's pointing to this any server service. And also we have all the analysis tools within use proximity. The create drive time areas tool is using the service area tool, and it's using the service area service. And it's working because we have registered the service area asynchronous service in the portal. The fan areas is going to use the closest vicinity service. Plan routes uses the vehicle routing problem service and route for a fleet of vehicles. Connect origins to destinations is actually using the route service because it's using the route to connect your origins to destinations. And within fan locations, you have the choose best vicinities tool, which uses the location allocation service. So this is how the map viewer is going to use it. So if you have Pro, and you can also use the service by going to Analysis, Network Analysis dropdown, and change your network data source to your portal. And now, if I make a service area, it's going to use the services that is registered with your portal. So let's take a look at our server manager. Currently, the geoprocessing service instance in use is 0. But if we create a new vicinity, and then solve our service area, run this analysis. If we're lucky, we will see that instance in use is 1. So we know that it's actually using the service to do our service area analysis in Pro. So all this suggested that publish routing utility tool is very useful and powerful, and is the recommended way to publish your routing services on your enterprise. So back to you, Dilash.
Thanks, Max. So Max just showed you the tool, and as I was mentioning, if you have a network data set and just want to use your network data set using routing services with many different out-of-the-box applications, the recommended approach is to just use publish routing services utility, so that takes out all the authoring and publishing that we have talked about previously. But sometimes publish routing services utility may not be the tool that gives you the services that you want to use. So there might be occasions where you want to still go ahead and publish your own geoprocessing service. For example, publish routing services utility creates routing services that just perform that one particular task that they are meant to perform. For example, if you publish a routing service, it's only going to do routing. What if you want to combine that routing capability with some other analysis? For example, you want to find a best route between your stops, but once you have found that route, you want to calculate an elevation profile for that route. So here you are combining routing with some kind of spatial analysis, in this case calculating the elevation profile using a digital elevation model. So in this case, you would write your own geoprocessing service and then work with it. Another example is, what if you want to combine multiple different network analysis in a single service? For example, you want to determine the accessible open houses and then find the best route to visit them. So in this case, we want to combine some kind of accessibility analysis and then actually do routing. So even in this scenario, you would publish your own geoprocessing service. Now, how do you go about publishing your own geoprocessing service? As we had seen earlier, we follow those 3 steps. You author a geoprocessing script tool using ArcPy and ArcPy.NAX Python modules. Then you publish that as a web tool, and then you share it and use it from many different applications. So let's look in some details on how do you write a geoprocessing script tool that can perform routing or network analysis. So you do this using the ArcPy and the ArcPy.NAX Python module. The routing part is done using ArcPy.NAX module. The other types of work in your Python code would be done by the ArcPy module. So when working with the ArcPy.NAX module to perform any kind of network analysis, you always follow these 5 steps. You initialize an analysis object. Now, ArcPy.NAX module comes with 6 different objects for 6 different solvers that we have. So depending on the type of analysis that you want to do, you first initialize the analysis object based on the specific network data source that you are working with. Then as a second step, you set the properties for your analysis. Third step is to load all the inputs. The next step is to solve the analysis, and finally you work with the results. Now these 5 steps are common to any type of network analysis that you will do using the ArcPy.NAX Python module. Now here I am giving an example of how do you work with an origin destination cost matrix analysis using the ArcPy.NAX Python module. Now this as part of this workflow, you would first initialize the OD cost matrix solver object. Then on the object, you would set the properties. You would use the load method to load your inputs. Then you will call the solve method. And then finally, when you call the solve method, you get a result object. And then on the result object, you can use export to export out the results. So here is an illustration of in code on how you can perform these steps. In this case, this example is generating travel directions. So let's look at some details on this example. So here I have a simple function called getDirections, which is generating travel directions based on a given travel mode. Now this is the code behind the script tool that I have written, which I can publish as a geoprocessing service and then can use it. So in the first steps here, I am first reading all the different inputs. Then I am initializing my solver object, route solver in this case. Then I am setting certain properties on that route solver object. So I first set the travel mode, then I'm setting the time of the day. So if I have historical traffic in my network data set, I can make use of it. And then because I want to generate travel directions, I am saying return directions to true. Then using the load function, load method on the solver object, I am loading all of my input stops. And then I am trying to solve my analysis. Before that, I need to check out the network analyst extension license. if my solve is not successful, now I got the result object. So using the properties and methods on the result object, I can then post process. So I'm first checking if my solve is successful. If it is not successful, I am just printing out all the messages so that I know why my solve was not successful. And if it is successful, I use the export method on the result object to export my directions into a feature class, which my service can return out to my clients. So let's switch back to our presentation. So this was an example of a script tool written using ArcPy and ArcPy.NEX Python modules. Now some tips and tricks when you're authoring geoprocessing services, essentially when you're writing geoprocessing tools, script tools that you eventually want to publish as geoprocessing service. Now you should use a network dataset layer instead of referencing a network dataset using catalog path. Now this is extremely important to get best performance. When you use a network dataset layer, the connection to the network dataset is opened only once when the service starts up, and after that the connection information is cached. So subsequently when you use your service, that connection is not being reinitialized. If you use a catalog path, every time you use the service, the connection to the network dataset is created, and that can be slow depending on where your network dataset is stored. So I would highly recommend you always use a network dataset layer instead of referencing the network dataset using its catalog path. Then when you're actually writing your script tool, you should do certain things. First and foremost, you should really write a script tool. Now in geoprocessing framework, you can actually create a geoprocessing model and then convert that model into a model tool and then publish that as a web tool. For routing, I would recommend not doing that because you will not get the best performance out of your geoprocessing model. Writing geoprocessing script tools that perform network analysis using ArcPy.NEX Python module is significantly faster than doing the same analysis using geoprocessing model tools. Now when you're creating your geoprocessing script tools, you should use feature set data types for inputs. This allows you to restrict the types of geometries that your tool can use as input. For example, if you are loading stops, you want to make sure that someone only passes in points and does not pass lines or polygons. By using feature sets, you can control this at the service level itself without actually writing code to handle different types of geometries and rejecting the geometries that you do not support. When you're writing outputs, you should write them to a memory-based workspace instead of writing to a file geodatabase workspace. This will significantly reduce the I/O that your service needs to do and so improve the performance. You should also, as a tip, avoid writing too many messages. Writing messages from your geoprocessing tool is slow. So you should either batch up your messages so that you minimize the number of messages, or don't write information that's not relevant for your script tool. Essentially, try to minimize the arcpy.add message and arcpy.add warning or add error calls. Only when it's required, do that. Otherwise, try to minimize those calls. So those were tips when you're authoring geoprocessing services. Now let's look at some other tips when you're actually publishing geoprocessing services. Now for most of your routing services, your end users or your service consumers do not need to specify the network dataset. So hide that from your service consumers by setting the input mode for that network dataset to be a constant. So that way the end users don't see that parameter at all, so they don't have to specify that. When you are publishing your routing services, you have to somehow tell the server where is the network dataset that is used for your analysis. For this, you should register the folder containing the network dataset as a data store instead of letting ArcGIS server copy the data. Why am I recommending this as a tip? Because by registering the folder, you are essentially controlling the location on where the data resides on your server. If you instead use the option of copying data, then ArcGIS server will make a copy of your data and store it in a location that's internal to ArcGIS server, and then you lose control of your data. So in future, if you need to do data updates, you have to delete the services and recreate the services again, which would definitely increase the downtime of your services. As opposed to if you are controlling the location of the data, you can just swap the data, stop the service and start the services again, and you will be back online. Next is you should if possible, not store the network data set on a file share. This is very common practice, especially when you are having a bank of servers that run your routing services. Most server administrators would take the network data set and put it on a file share that's accessible to all the servers. Now, accessing the network data set from a file share is slower, and the routing services need to access a lot of content from the network dataset. So the faster the I/O between your service and the network dataset, the better the performance will be of your routing service. So in a multi-machine scenario, or even when you're using a single machine, definitely copy the network dataset on each individual machines, and if possible, make sure the data is stored on a locally attached SSD drive so that you get the best possible performance with your routing services. Now, with those tips and tricks in mind, I will hand it over to Max, who is going to show us how to create a geoprocessing script tool to solve a particular workflow, publish that as a geoprocessing service, and then use it from different applications. Over to you, Max.
Okay, thank you, Dilesh. So in this demo, I'm going to show you an interesting workflow, and I will show you how to solve this problem and why we want to create a custom geoprocessing service for this workflow. And I will show you how to publish your own geoprocessing service and use it. So for the context, I'm a real estate agent, and my job is to provide my customer with a list of open houses and help them to figure out which open houses fit their criteria better, and also plan a route to visit all the selected open houses with them. So one of the criteria my customer has is that the open houses needs to be closer to the nearby grocery stores. For that, I can do an accessibility analysis on the open houses, and I can calculate the distance from each open house to all the nearby grocery stores and calculate the accessibility index. And I can use origin-destination cost matrix analysis to figure the distance between all the open houses with the grocery stores. And then for the open houses we selected, we need to plan a route. Since each open house have their individual time window, and we also have to spend around 30 minutes in each of the open house. So we need to plan the routes carefully. So for that, we can do a traveling salesman analysis to find the best route with time window, and we will use the route analysis for that. So as you can see, the workflow requires several network analysis tools, and we don't have out-of-the-box solution for that. This is when you need to create your own tool and solve the problem. And if you want to later share this workflow with other coworker or want to use it on the web, then you need to take this workflow and publish as a service. And I will show you how to do this. So here is a script tool called Open House Tool for, which I created to solve this problem. So let's take a look at the tool parameters. So first is a customer home address. We can click the pencil to click on the map and specify our customer's home address. And for the open houses to visit, these are all the open houses we have and we want to visit today, and each have their respected time windows. When do they open, when do they close? For the network dataset, I'm just going to use the San Diego network dataset layer that is within my map. And then for the point of interest, I'm going to use the grocery stores in San Diego. So these are my grocery stores. And for the travel mode to calculate accessibility, if you don't want to do walkability analysis, you probably want to use the walking distance. And if you are doing a walking distance, you probably want to walk within 1 mile. So our cutoff in mile is specified to 1. And then the travel mode to calculate route, since we are driving our vehicle to route to go to all the open houses, so we are using the driving time. So let's get it running. And while it's running, I will show you how I author this tool. So let's go to the properties of this tool. So within the properties, we can go to parameters and see how I define the parameters. So first, for the home address, I'm specifying a feature set, so I can do the interactive editing as I just showed you. But the feature set can take all sorts of input data, points, polygons, and lines. But if you want to limit to only one type of the geometry, what you can do is you can specify a default that points to a layer file. And the layer file will point to a feature class, which defines the geometry for the feature class and also the schema for the feature class. And the next important thing I want to show you here is the network dataset. Here we are using a network dataset layer, and also Dilesh have already explained to you what is the performance benefit of using the network dataset layer as a data type. And next, I want to show you the travel mode. So for the travel mode, we have the dependency of the travel mode coming from the network dataset. This is something we recently added. And the benefit of doing this way is that all the travel mode dropdown will only have the travel mode supported on the network dataset. And then for the output, if you want to customize the symbology, you can specify a symbology layer for the output. So here we have already finished the tool running, and let's take a look at our result. So we get a route that starts from our house, visit all the open houses in sequence, and then comes back to our the customer's house. And on each of the open house, we have what is the sequence of the house that we visit, and what is the accessibility score of the open house. And we have a line connect to the open house to the nearby grocery stores. And on each of the open house, we have the time window 9 to 12. And we arrive there within our time window, and we spend 30 minutes within each of the open house. Take a look. The accessibility score is only 1 because we only have one grocery store and it's pretty far away. And if we take a look at this guy here, we'll probably expect the accessibility score to be higher. So this is how I ran this tool. And let's take a look at how the tool actually executes by looking at the code. So here is the code for the script tool. So first, it gets the tool inputs, and then do a little bit setup here. So one of the important things I want to highlight here is this scratch folder. So remember, our goal is to take this script tool and run it on the server. So in the server, if you have to write some intermediate data, you don't want to specify an actual path. The reason is because every job that you execute on the server is going to write the data in the same path. That way, it will eventually run into a conflict. So the scratch folder is here to take care of the scenario. And the scratch folder, it will be different for each time when you submit a request to your server. It's going to create the scratch folder within the job folder. So it will be guaranteed to be unique every time. So if you have any intermediate data you want to write on the server, write into the scratch folder. Next, we do our accessibility score analysis. For that, we use OD to figure out the distance between our open houses and all the grocery stores. We set some OD settings, set the travel mode for the cutoff and distance. So within our tool, we set it to be 1 mile. And then we load our open houses and all the grocery stores to origins and destinations. And then we solve. If solve doesn't succeed, we add all the warnings and the error messages. And then we export our result into an in-memory feature class, because Dilashi already explained what is the benefit of using the memory workspace on the server context. And then we calculate our accessibility score. So what this piece of code is essentially doing is looping through all the open houses, finding all the grocery stores nearby, and within of the grocery stores, get the distance between the open house and the grocery store. And we are assuming that the attractiveness index of the grocery store decays exponentially if the distance between the open house and grocery store is further. So the total accessibility score of the open house is based on all the groceries nearby. And then next, we want to initialize our route object to do our route analysis. For that, we set up some routing settings. For the time units, we want to be minutes, and distance units to be miles, because that's how we want to specify our inputs and outputs. And then set our travel mode. And because this analysis, we want to start from the customer's house, route to all the open houses with the best sequence, and then come back to the customer's house. So we want to return to start, find best sequence, and preserve the first stop. And first, we load the customer's house. And next, we load all the open houses. So on our open houses, we have a field called start time, end time, and visit time. And on our internal stops, we have time window start, time window end, and additional time. Because we don't know your data schema, and we can only predefine our data schema. So on our data, we have time window start, time window end, and additional time. Essentially means the same thing on your data. So for us to know that your start time means time window start, you have to do the field mapping. And then for the additional time, if the visit time, you don't specify a visit time, by default, we give it 30 minutes for each of the open house. Then we solve our routes. And again, we write our result in the in-memory feature class. And what you can do here is you can, after you solve get the result, you can save the route data into a zip file. Essentially, it's a geodatabase with all the route information. And after you save the route data in the Scratch folder that I just explained, you can take the zip file and use shared route layer to share this route data as a route layer. And then if you have a Esri navigator, you can connect to your portal, get the route layer into your navigator, and use a pre-planned route for your route analysis. And then after that, you clean up some intermediate route data. Because we don't have too much time, so I couldn't go into detail of all the script, but I will share the script along with the demo to you after you get the slides. So here, once you have successfully run this tool, what we can do is we can go to the history pane and take this tool and share it as a geoprocessing service. To do that, you can right-click on the history item, click Share As, Web Tool. So what you can do is you can specify the name of the web tool, a summary, what this tool is doing, and then you want to publish by reference, and Dilesh already explained the benefit of publishing by reference. And then go to configuration. You want to set your message level to be warning, so all the warning and error messages are returned from the server to your client. And then for the content, where you can configure how your inputs and outputs behave. So here, you can click Configure. For the home address and also the open houses to visit, we want each time to be different because we have different customers and open houses. So we want to choose user-defined values. And then for the network dataset, we want to be constant because you don't want to specify network dataset when you run the network analysis service. We will always use the San Diego network dataset for our analysis. For the point of interest, we can mark it constant because we will always use the grocery stores in San Diego in this case. For the travel mode to calculate accessibility, because it's a distance analysis, so we can turn off all the time ones. And also we probably don't want the tracking ones. And we can do an analyze to figure out if there is any error. And we found we have a one warning. It essentially tells you the network dataset has not been dissolved. And you can go ahead and dissolve and it's going to go away. But for now, we can just ignore it. And we can publish these services as a web tool. And it's going to take a few seconds, but I have already published here. So here, what you can do once you have published your service is you can run it either in Map Viewer or in Web App Builder or directly hitting against a geoprocessing service. But what else you can do is you can take it and run it within Pro as well. And I will show you how to do that. So here I have another project which doesn't have my processing tools here. So what we can do is we can go to portals and take what I published, this open house demo, and it will show up here. So now if we open it up, it's going to connect to my portal and find the tools for me. So still for the home, we can specify our home address. And then for the open houses to visit, these are my open houses, the same data. But then you can see that we don't have the network dataset or the POI layer because we have already made it constant when we publish our service. And then for the travel mode to calculate accessibility, we only have walking distance and driving time distance because in the choice list, we only give these two choices. And you can get it running. So in this case, we don't specify the output feature service name, which means we're not creating a feature service for our output. And if you put the feature service name, it will create feature service. And what it's going to do here is it's going to create some feature connections for our output. So what it's doing right now is essentially it's packaging all the data and send to the server. And then the server is going to, since we have already published our service to the server, so the server is going to execute our logic that we specify in our script. And once the server finished processing, it's going to package the data and send it back to our client, and then our client can render this data. So the feature collection is essentially just some type of JSON that our software can understand. It's going to take a few seconds. It's probably taking longer here because my network connection it's using Wi-Fi, it's not as good. So we have our result back. And what we can see here is it's finding us. So what we can see here is it's finding us the route and give us the route that we are requiring, and also the open houses. And it preserves our pop-up for each of the open houses. And what is the accessibility score, what is the time window. And also one more thing I want to show you is on our route object, our route result. We have this route layer that we calculated. So if you open it up, and then you can share this route layer to your navigator, and then your customer can open it up in the navigator, or you can open it up in the map viewer, and then you can also open it up in the directions pane, and it's going to tell you it starts from the customer address and visiting all the houses in sequence, and also return to the open houses. So this is a workflow that you author this geoprocessing service, publish it as a you author this script tool, publish it as a geoprocessing service, and then consume it back in Pro. So back to you, Dinesh.
Thanks, Max. So with that, we will wrap up this presentation. I am putting out some links to the resources. So I talked about the network analyst concepts. So here is a detailed link to the documentation that describes all the different solvers and what type of analysis you can do. Then there is a link to how you go about performing network analysis using web services. Then a link on how do you publish routing services, which includes the geoprocessing service and map service with network analysis capability. It also has a step-by-step tutorial on how do you write a script tool and then publish that as a web tool along with some data that you can play with. And then finally the REST API doc, once if you have to use these services in your own applications programmatically through the APIs or the SDKs that ArcGIS provides. And finally below is the URL from where you can download all of these slides and all the demonstrations that Max showed during this presentation. Thanks a lot for your time watching this presentation.
Thank you.